it is again recording, right?
Okay.
Okay. So, for example, family members' income and expenditure are the three variables. Family members and income are the independent variables and nominal data, and expenditure is dependent variable and scale data. So, we will observe here, is there any significant differences of amount of monthly income and the amount of monthly expenditure on shampoo purchase? Is there any significant difference between number of family members in house and expenditure on shampoo purchase? So, if we consider the hypothesis like this, if we have three null hypotheses, amount of monthly expenditure on shampoo for different income do not differ. Okay. Secondly, the amount of monthly expenditure on shampoo for different family members in house do not differ. And third number null hypothesis is amount of monthly expenditure on shampoo for the interaction of income and family and member of the family and number of family members do not differ. So, it is the interaction between when income and family members both are changing, then what will happen on shampoo purchase? Either expenditure will increase or decrease like this. So, and alternative hypothesis would be just opposite of that. So, how to do it? You will go to analyze and general linear model. You have to go to the general linear model. Then you are watching. Need to. You are watching my screen.
Yes, sir.
Okay.
Yes, sir.
Okay.
Yes,
Okay.
you're watching your
General
screen.
general linear model. Then select the univariate. Then what you will do in dependent variable, you will select the your expenditure is dependent variable and other two factors, that is monthly income as well as family members will be the your independent variable or the factors. So, see what the results will come. No need to do anything, just okay, the result will come.
Sir, I'm sorry. If you repeated one more.
Okay. Let's open the file number 15, 2OA ANOVA. Please open this one. Family member, income and expenditure. So, how to do it? Go to analyze and go to general linear model and go to univariate. Okay, here expenditure is our dependent variable. Everybody opened it? File number
Yes, sir.
15,
Yes, sir.
2OA ANOVA. Just select this one, independent monthly expenditure, dependent variable, and other two as fixed factors, income and expenditure, sorry, income and family members, and keep everything as it is. No need to do anything. Okay. Okay, no need. Just okay. And see the result. Just a minute. Okay. Here, see. Here intercept with intercept means when a family member and income both are changing, both has increase or decrease. Okay, then if it is like this, is there any significant? It has only significant, that is less than 0.05. But if the family members do not have any a significant effect, if if our hypothesis, if our family members is increase, then purchase on the shampoo, the expenditure do not change. But with the changes of income, there is no significant significant changes coming in the expenditure on the shampoo purchase. So so only when the intercept comes, suppose your family members also increase and your income also increase, in that case when this intercept comes, both are changing and increasing, in that case a significant difference coming in expenditure on shampoo purchase. That is the result. Here you see monthly income, okay, dependent vary amount of monthly expenditure on shampoo, intercept. Here see the result. Since the income and family members with expenditure values are more than 0.05, therefore null hypotheses are accepted. However, for intercept, this is the intercept. For intercept, null hypothesis is rejected as the p-value is less than 0.05. So how can we explain this? So the explanation is that with the changes of income, no significant changes comes in the expenditure of shampoo purchase. If the family member changes, there is no difference or no changes comes, no significant changes comes in expending in purchasing shampoo. And when both are changing, family member and income is changing, then significant differences comes in shampoo purchase. So this is how we explain two-way ANOVA. Then the last ANOVA is one-way repetitive measure ANOVA. Okay, one-way repetitive measure ANOVA, analysis of variance, is a common and robust statistical test that you can use to compare the mean scores collected from different conditions or groups in an experiment. Okay. So suppose we have three teaching methods. One is teaching method 1, teaching method 2, teaching method 3. Okay, we have the students of 15 sample. So in teaching method 1, what was the result, and in teaching method 2, what was their score, and what is in teaching method 3, what was their score. The same sample with different methods been used. Is there any differences, significant differences in teaching methods, in teaching methodology, in obtaining the results of the students or the scores of the students? So in null hypothesis, there is no significant difference among the three different teaching methods. Alternative hypothesis telling there is a significant difference among the three different teaching methods. How to calculate this? Just you will go to analyze, then general linear model, and after going general linear model, you have to select repetitive measures. Then you will select the methods first, then number of levels 3, then add, then you will give the teaching method 1, 2, 3, and then you will select from the options that it is descriptive statistics, and ensure that it is
Doctor,
less than
which number of data are you using?
Huh?
Sorry, data number what, sir? Sorry,
Okay, data I shall tell you, inshallah. Just give me a second. So just the 16 number, please open this one way repetitive
thank
measure
you.
ANOVA. Everybody please open this one. This data set will come. Okay, so this is the student number of students, method 1, method 2, method 3, and we will go to analyze and general linear model. Here general linear model, please everybody follow me, and go to repetitive measures. Go to repetitive measures. Here you will write here methods, methods, methods. Number of levels is 3 methods. Okay, then add. Okay, then define. Okay, are you following, or I shall do
Yes,
once
sir. Yes,
again?
sir.
Huh?
No, sir. But I am able to follow, sir.
Okay, I am going and again. Go to analyze, general linear model, repetitive measure, repeated measures. So just click on there. Here within subject factor name, our subject factor name is methods. 3 methods, and we have we already here methods, and here is 3. Just add this, then methods, 3 methods are done. Now after doing this, I think until here everybody have done this, right?
Yes, doctor.
Yes,
Okay.
sir.
Yes.
Then
Yes.
click on define. Okay, so we have these 3 methods. We can take all these 3 methods together to this right side within subject variable methods, and just click on option here, just descriptive, select the descriptive statistics, nothing else. Here it is automatically 95%, significant level less than 0.05 would be. Okay, once you have done, then continue. Everybody, is it okay?
Yes, it's okay.
Yes, yes.
Okay, then okay. Okay, method 1, method 2, method 3. The mean score of method 1 is 63, method 2 68, and method 3 82. So we will is there any significant differences among these teaching methods? By these teaching methods, what's the scores obtained by the students? Is there any significant differences of this mean value? So how can we so here sphericity assumed that here different people has recommended different one within that subjects effect. They have suppose greenhouse gases, Heinfeld, lower bound. So they have suppose greenhouse gases. His recommendation is much more better. So here mean score it is showing the significant value is 0.000. So here we can even in here it is showing that all this even Hein field and sphericity assumed all are showing the significant value. Okay, so from these we can come into the conclusion that there is a significant differences among the teaching methods. How to explain this? Here one way repeated, since the p value is less than 0.005, the null hypothesis is rejected. Therefore we can say that there is significant difference among the teaching methods. So this is how we do the one way repetitive measure ANOVA. Okay, now we shall do the correlation test. This is most important, those who are in social science research, and correlation and regression test. Who can explain what is correlation? Why we do the correlation? Can you explain the theoretically what is correlation between two variables? Why we do this analysis? Why we do the study?
It tells about
Yes,
the relationship between two variables. If one variable increases and the other one increases also, it means there will be a positive correlation. And if the value of one variable increases and the other decreases, it means there is a negative correlation. And if the value of correlation is near to 1, it means there would be a strong correlation.
Yes, it would be in between -1 to +1, right?
Exactly.
Okay,
Yes.
mashallah. For example, war in Ukraine and the inflation in Pakistan. Okay, is it okay? Example?
Yeah, it's a positive correlation. Yeah.
It is positive correlation. And can you give the negative correlation example? Negative correlation example. Suppose okay,
May I tell, please?
more supply,
May
less
I tell,
price.
please?
Price
Supply and
reduce,
demand.
right?
If I just to make a model like a negative correlation, like the income level and the higher income level and the level of education. So we can just put a model that is the negative correlation, right?
No,
The
no,
two
no,
things,
no, no,
I mean,
no. Higher education, higher income. It is positive correlation. But
Higher
suppose,
education, higher employment.
huh?
Higher education, higher employment.
Yeah. Yes, brother Raghavendra Yadav. Yes.
Sir, can you
Increase,
say higher
sir, I want to add something.
Okay, one.
higher
No,
price
no.
and lower purchase?
Yes.
I want
So
to
supply and
I
demand.
want to add something.
Yes, one by one. We'll listen everyone. We'll learn and
Okay.
we'll have more example from you, inshallah.
One simple example is that increase inflation, decrease purchase level.
Okay.
So it is basically a negative correlation.
Yes. Another example who can give?
I
Anu, he is
Doctor,
very
sir?
nice. Yes, Anu Torino.
Yes, sir.
Yeah.
Yeah, demand and price, price and
Demand and
demand.
price. Yes. If demand, no. Supply and price.
Let me
Yes.
explain, sir.
More
Let me
supply,
explain, sir.
less
Let me
price.
explain, sir.
More supply.
Let me explain,
No,
sir.
sir, price and demand.
Sir, education and marriage.
Okay.
Education and
Price
marriage. Marriage.
how will you explain, sister?
Let me
Supply
explain,
and
sir.
demand.
When the price of any product will be increased, then the purchasing amount will be decreased automatically. If
Nice. More price, less demand.
purchase,
Okay.
yeah,
Less purchase.
less purchase, yeah,
Less
same.
purchase.
Another example I want to give over here, that height about sea level and temperature. As you climb the mountain, increase in height, it gets colder and decrease in temperature.
Mashallah, very nice. Yes,
Oh,
sister
sir,
Sarah. Yes.
if students' absenteeism increases and grades are decreases, then the grades are decreases.
Again,
This is
again,
example of correlation.
again, sister.
If student absenteeism increases
Absenteeism increases, the
and grades are
decreases.
decreases.
Mashallah. Negative correlation. Yes.
Yes, sir. May I raise another one?
Yes, please, brother.
Like, first of all, the positive correlation. According to the demographic situation, I mean, demographic dividend, the in between the people and the productivity is the positive correlation. The dot is people, the old age people productivity and the productivity level. That is a negative correlation,
Yes,
right?
Okay. Is a certain age, after certain age, the productivity
will be decreased, some extent decrease. I mean that people before, I mean more than 70 years of age on an average, their productivity, I mean much more less, comparative to, I mean, a high productive area like 25 to 50 or 55. Okay, thank you.
Yes,
Sir.
brother Jia. Yes, brother Jia, Dr. Jia, please. I think Dr. Jia, right? You are from Pakistan, right? Dr. Jia.
Assalamu alaikum.
Walaikum salam. Please
Yeah,
raise your voice. You are such a great doctor. Join this workshop. Please contribute
Assalamu
on our
alaikum.
concept.
Am I audible?
Yes.
Okay, fine. I'm from India, doctor.
Okay.
I just joined. I was in a conference.
Okay.
So again, I continued attending your discussion.
Yes.
And it's quite insightful, in fact. Yeah, please.
Okay. We
Let us
were
go ahead.
talking about a positive correlation and negative correlation, like that. Yeah.
Demand, supply, and demand and price, supply and price.
Yes, demand.
Like
and price.
demand will increase, then price will increase.
It is the positive. Okay.
Positive and negative with supply. If supply will increase, then price will decrease.
Mashallah. Thank you, brother Yadav. Okay. Thank you. Yes, Abu Khan, please.
Ayub Khan. Yeah, sir. If consumption of junk food, health condition decreases.
Okay. That is the negative correlation. Yes.
Yes, a negative correlation.
Okay. And positive correlation example, brother?
I mean, like better exercise, doing good exercise, keep your health fit. Health condition get increases.
And another one is that like
Better physical
the
activity.
level of investment and the tax rate. Okay, the negative correlation. Level of investment and the rate of tax. Negative correlation.
Yes. Mashallah. Mashallah. We got many examples. Yes, please.
We can give another example with the consumption of fast food, that the consumption of fast food, if it is increased, then the obesity also increase. That is the positive correlationships, I think.
And negative is health condition decrease. That is consumption of your. Okay, just okay. Very good. Okay, it is clear now. So,
doctor, I want to ask a question over here.
Yeah.
What will then we call a zero correlation?
Okay. Zero correlation. Okay, you explain better, brother.
I think so. Yes, please.
Yes, please.
Yeah, okay. The zero correlation is that the two variables are totally, I mean, independent to each other. So there is no in-between correlation. That is the zero correlation. Thank you.
I will give an example. For example, we say that tea drunk and level of intelligence. So there is no relationship or no association between how much we intake the tea and the level of intelligence. Am I right?
Yeah, it is nearly, maybe it is nearly zero. Maybe some correlation, but it is negligible. It is near to zero. Okay, that's why we have a range where we can say strong correlation, moderate, low, or no correlation, like this. Okay.
Sir, simple correlation, multiple correlation, and partial correlation.
Yes.
On
Some
the
other,
basis of the
suppose
quantity.
like this, if the values are value in between 0.75 to 0.95, then a highly positive linear correlation. If the R value is 0.50 to 0.75, then medium positive linear correlation. If R value is 0.25 to 0.50, slight positive linear correlation. R from 0.10 to 25, weak positive linear correlation. If it is less than 0.10, then we can say it is independent, no correlation or no significant correlation. Right?
So there is two type of correlation on basis of the variable, like linear and purely linear.
Linear and
Curvilinear.
okay. Okay.
Sir, it better that in practical case, maybe this is not the R square. I think that it should be adjusted R square. Is it right?
No. It is the value of R, neither R square or adjusted R square, that we measure for the model fit. But here the correlation value we measure by the R, small r.
Exactly.
And
the range
capital
is
R. Yes.
and the range, the small r range is from -1 to +1.
Yes.
Theoretically, zero is correct, but I think there is no relationship, so we cannot consider that with the independent variables or such variables that they have no relationship among them for the zero.
Yes. Okay.
The curvilinear, we can say that non-linear.
Yes. What is the meaning of linear and non-linear, brother Shahriar? Can you explain, brother? What is the linear means and what is non-linear means?
Sorry, I have interrupted internet connection. Can you again explain the question?
What is the meaning
What is
of
linear?
Linear means linear correlation.
Linear correlation.
Okay. I got it. A linear means something we say that it will be linear to a particular line. In mathematics, we can draw all the linear equation to construct a line. A non-linear equation is such which does not form a straight line. Means there have certain point of deviations.
For example. For example, suppose in this case, suppose ways and welfare and fringe benefit all together, these are the linear, right? Linear effect on the employee performance. Is it okay? Suppose multiple linear regression that we are observing. So in that case, so these are the similar type of homogeneity of the variables from which we can consider it is the linear regression, right, brother?
Exactly, it is same. I will give one example of non-linear correlation. That when the ratio of variation between two given variable changes. For example, in 20% increase in the income, the expenditure sometime increase by 5%. sometime by 10% or sometime by 15%. Hence, we call it that the correlation is basically non-linear correlation.
And if it is, how we can say it is linear correlation?
When there is consistency, that the increase in income and the expenditure is consistent 5% or 6% or 8%.
Oh,
not a big difference between the percentages.
Like give me one example, theoretical example, so that very nice, brother. I am impressed of your answer.
Hello, sir.
Just 1 minute, brother. Give him chance to give the example.
Like for example, if we say that our income is 40% increases, for example, and at a unit time we saw that our expenditure is increased by 5%. So, once a time, and another time we see that this difference is large, up to 40%. So we say that it is a non-linear correlation, okay, because at 2 point of time there is a big difference between the obtained value.
Okay, how about the linear example?
Hello, sir.
Yes, please, brother, please.
I just want to add to his contribution.
Yeah.
So if you needed an hypothetical example, then we'll be talking about oil price. You know, variables that are subject to shocks, they are non-linear. And those ones that they tend to have relatively stable value over time, they are linear. So if you are comparing oil price with exchange rates, especially for countries that are import dependent, then you can say exchange rate and oil price have a non-linear. So if you are a country that is import dependent, you find that the export oil, you find that when there's a shocks in international market in the price, then there will be a gap in successive year prices of that oil for the country. And for exchange rates, you see that the movements may not have too much gap, probably because of policy and some factors. So we can use oil price and exchange rate movement. So if we're interested in non-linear.
Okay, a simple example of linear correlation. A simple example. Can you give us, brother?
A simple example is income and expenditure.
Okay.
It's a linear income and expenditure because you tend to regulate your expenditure on the basis of your income. So there may not be a wide gap for successful monthly income and expenditure, except in few cases.
But our brother was giving one example that if your expenditure is, suppose your income increased 40% and somebody's expenditure increased 5% or somebody's 10%, 100%, like this. So it is he's giving using it as non-linear. But
that's a rare case. A rare case. Mostly we cut our expenditure according to our income. Yes. So it will be following. Except if there's a shock, an upsurge in your income, probably you receive a grant. You want to expand your expenditure in a upward version because you have a shock in your income. Probably just receive a grant, a gift that raise your income level very high. So you may want to even raise your income. But in economic theory, we believe that you may want to raise your expenditure. But in economic theory, we believe that the expenditure will still not change because it follows permanent trend of your income. your expenditure. So there are rare cases you can have a shock in your income that you have a huge gap in your expenditure. So, but most cases, expenditure and income follows a linear pattern.
Okay.
Yeah.
Okay.
So,
what's your name, brother?
Toriola.
Tobiola, I would like to see you, brother.
How
can I see you, brother? You're very knowledgeable. I appreciate your knowledge, brother. That enhance our alhamdulillah knowledge, alhamdulillah. So Daniel,
Doctor,
right?
can I add something? Doctor, can I add something?
Yes, please. Okay, please.
A simple one. Johanna.
Johanna. Okay.
The relationship between sales and profit. For example, sales increased 10%, profit also increased about 10%. So it is a positive relationship. So this is an example of a relationship between sales and profit.
Okay. Sales and profit. Okay. This is positive. Okay. Is it linear or non-linear?
Linear. It's linear.
How can we define it is linear correlation?
Actually, linear is the increase of the sales and the profit is aligned with the increase of sales.